Okay, I'm going to try to make this as painless as possible. I'm not going to go over the acceleration uh, equation much because I went over that today. But if you need any help actually solving the acceleration equations or the speed equations for that matter, just go ahead and email me and we can set up a meeting. What I'm going to be going over mainly, which I think is probably the hardest part of this whole thing, don't freak out when I show you this, is the graphing. Okay, so, but before I get to that, I want to make sure that you understand, today I showed you the units for acceleration. I drew them like that, but what you actually write is meters per second squared. And I'm going to show you why that is, because they don't really explain that in the videos, why it's written differently. So I'm going to start here. I'm just going to put, I don't know, 5 meters per second per second. Okay, and I'm going to get rid of this 5. And I'm going to rewrite this a different way. Okay, what this is really saying is meters per second over, whoops, over seconds. Okay, hold on a second. Get my cap. Okay, so what this line means right here, and you should all know this really, what this line right here represents is divide. Okay, so I'm going to take this S right here first, and you can put anything over 1. All right, 2 over 1 is 2, 100 over 1 is 100, right? I can put any number over 1, okay, and it's just itself. So I'm going to take this S and put it over 1. Okay, so it's meters per second divided by seconds over 1. I'm going to rewrite this, though, in a different way. Okay, I'm going to put meters per second divided by seconds over 1. Now, if you know how to solve this, what you have to do is take this and flip it. Okay, so I'm going to do that. I'm going to go meters per second, and then I multiply it. So multiplied by 1 over S. And when I do that, what I get is meters per second multiplied by itself squared. And that's why the unit is written meters per second squared. Okay, so, but you still need to remember, like I went over today, that really what it means is a speed increase or decrease every second. Okay, so if I had my original 5 meters per second, it would mean that the object is speeding up 5 meters every second. So if you started at 0, it would be after 1 second, you'd be going 5 meters per second. After 2 seconds, you'd be going 10 meters per second. After 3 seconds, you'd be going 15 meters per second, so on and so forth. Every second of time that passes, you increase your speed 5 meters per second. Okay, so that's why the unit is written like that. Okay, now the graphing. I'm going to do speed first. Okay, and this is tough because some of you are in IM1 and some of you are in Math B and C, and some of you might not have even seen slope before. Let me move this in a little bit. There we go. Okay, so all slope is a calculation of how steep a line is on a graph. Okay, actually, I'm going to cover this up so you're not freaking out with all the little numbers and stuff. We're just going to concentrate on this section of the line right here. Okay, slope is, let's see here, make sure it's in view. Okay, slope is the change of x. Okay, delta, little triangle in math means change, which just means subtract. Okay, so the slope of a line is, sorry, my shadow's getting in the way, is the change of the y-axis divided by the change of the x-axis. Okay, so if I look at my my graph here, okay, my change of y, I start at 10, right? This is the y-axis right here, right? So my change of y, I start at 10, I go to 25, right? So I started at 10, I go up to 25. How much did it change? It went up 15, okay? So I put that in, right? How much did y change? 15 meters. Okay, so now the change of x. I started at 2. 1, 2, 3. Oh, I did the math backwards. Hold on a second. It's 3. I start at 2. I get to 5. It's 3 seconds. So that's 3s. Sorry, I don't want to stop the video. Okay, sorry. Okay, so change of x is 1, 2, 3. So I put that here, and all I do is do 15 divided by 3, which is 5. Okay, so now you got to put the units. And if you were in here, you would learn real quick that units are really important. What is the units on the y-axis? Meters. Oops, meters. What is the label of the axis on the x-axis? Seconds. So you got to put that in there, right? Meters and seconds. And what you get is a speed. So the slope of a line of a distance versus time graph is the speed of the object. Okay, so now we're going to go to the B section. And just to explain it, just to looking at it, time continues to go on. Time never stops, right? So this is distance. So from 7 to 12 seconds, the distance is not changing, okay? Ultimately, the speed is going to be 0, right? It's stopped. Okay, but I can calculate that. I can show you how to calculate that. So again, we write our slope equation. The change of the change of y, well, it didn't go up any, so it's 0. Change of x, 5 seconds, 7 to 12, right? 12 minus 7 is 5, right? 1, 2, 3, 4, 5. So it went over 5, right? But 0 meters divided by 5 seconds is 0 meters per second. So it stopped. It stopped, okay? So going on to the C section, okay, it's the same thing. It's the same problem over and over and over again. Okay, so for C, my change of y is 30, right? I started at 50. I went up to 80. Okay, so the change is 30. 1, 2, 3, 4, 5, 6. So 5, 10, 15, 20, 25, 30, right? It went up 30. And then it over 4 seconds. So 1, 2, 3, 4. So the change of x is 4. And all I do is plug that in. Change of y over change of x. 30 divided by 4. I get 7.5. Okay, so the steeper the slope, the steeper the line, the faster it's going. Okay, and I know that's part of the lessons, but calculating slope. Okay, all you need is this equation: change of y over change of x. You plug in the numbers and you just divide. Okay, now that's just speed. That's just speed. Okay, for acceleration, it's a little bit different. Now you got to remember, you got to pay attention to the axes. This is distance, this is time. If you get a straight line on a distance versus time graph, it's speed. Okay, because with your slope equation, you're going to get meters per second, or a distance over time. This is different. this is a speed versus time graph. And if you look at a speed versus time graph, you should think in your head automatically acceleration, okay? If you see a distance versus time graph, you're probably dealing with speed. If you're dealing with a speed versus time graph, you're probably dealing with acceleration. But the process is exactly the same, okay? So if I look at my A section here, okay, my A section, slope is change of y over change of x. That does not change, okay? My change of y is 15 meters per second. You have to pay attention to the axis, the label of the axis. Okay, so my change of y is 15. My change of x is 3. 1, 2, 3. I plug that in, and I get 5 meters per second squared, right? It's 15 meters per second divided by 3 seconds, right? That's what the x-axis labeled. And what you get is 5 meters per second, or 5 meters per second squared, like I explained before, okay? The B section works exactly the same as it did in the other graph. Change of y is 0. Change of x is 5. You just count 1, 2, 3, 4, 5. But 0 divided by 5 is 0. So the acceleration is 0. This is tricky. The acceleration is 0, but it's still going. Okay, it speeds up. It doesn't stop. It for 1, 2, 3, 4, 5 seconds, it's traveling at the same speed. Okay, it doesn't stop. That's why you have to pay attention to the axes. Like, what are the axes telling you? On a distance versus time graph, a straight line means stop. On a speed versus time graph, the object is traveling at a constant speed. It's not accelerating, it's traveling at a constant speed. And then again, I mean, C, it's the same thing. Change of y over change of x, 15, and you can just trust me, like these numbers, right? The change of y is 15 meters per second, and you can count it if you want, but 15 meters per second over 2 seconds, okay, 17.5, right, meters per second squared. The steeper the slope, the higher the acceleration, right? A was 5 meters per second squared, and C is 7.5 meters per second squared, okay? So speed, right, distance versus time, acceleration graph, speed versus time, okay? Let me make sure I said that right. Speed, yeah, distance versus time, acceleration, speed versus time. Now, this is where it gets, where they're going to throw you a loop, okay? Here is a distance versus time graph. This is a constant speed, right? And you could find out the speed of this object just by, calculating the slope. What's the change of y? What's the change of x? Like we did in the other one. This is the tricky part. I'm going to show you, I don't want to show you it wrong, because sooner or later you guys are going to be in a physics class and you're going to say, wait a minute, Mr. Riley said this and that. No, I'm just going to show you the idea behind this. If I take the slope of this section, now I know it's a curve, right, which is where the problem comes in, but just for an example, okay, here is the slope in this section of time from 2 to 5 seconds. This is the slope. If I go up here, okay, if I go up to, let's say, this section here, the slope is steeper, okay? So we're talking about speed, right? We're talking about speed. So if this is A and this is B, A has a, well, let's go the other way. B has a steeper slope than A. So what is this object doing? It is accelerating, okay? This is slow, this is fast. How can you tell? Well, the slope of this one is steeper, this section. Okay, so on a distance versus time graph, a straight line is constant speed. On a distance versus time graph, if you get a curve, it's accelerating. Acceleration, speed. Okay, that's it. That was 15 minutes. That's plenty. Hopefully this kind of helped you out. Yeah, hopefully it wasn't 15 minutes wasted. So if you have any questions, please email me, and I'll be sure to get back to you as soon as I can. Okay, thanks everybody.